Upper and lower bounds are basically the reverse of rounding. What we're saying here is a bag of potatoes is 9 kilograms after it's been rounded to the nearest kilogram. So what could it have been before it was rounded? So if you are rounding to the nearest kilogram, I'd like to imagine a ruler marked out in units of kilograms. So here we are. You could have rounded it to 8 or 9 or 10 to the nearest kilogram. So what you're looking for are the places where you stop rounding one way and start rounding the other way. So that's obviously 8.5 and 9.5. That's what the upper bound and the lower bound mean. So in this case the question has 6 bags. So the heaviest that 6 bags could be is 6 lots of 9.5. And the lightest they could have been, if they were all as light as possible, would be 6 lots of 8.5. People get a bit confused about the upper bound. Yes, I know it couldn't actually have been 9.5 because then we would have rounded up, but that's what the definition of upper bound means. What's the first value that it could not have taken? Okay. If you had said 9.4, then you'd have the problem, well, it could have been 9.41 or 9.42 or 9.43. And if you'd said 9.49, well, what about 9.499 or 4999? So the definition of the upper bound is the one that you're allowed to get infinitely close to, but you can't quite take, whereas the definition of the lower bound is the first one that does round to your answer. Pause the video for a moment, have a go at the next example, and then I'll show you what the answer should have looked like. Okay, so it's been given to 3 significant figures. So here we are, 1, 2, 3 significant figures. So really, in this case, that's just another way of saying it's been rounded to the nearest 0.01. It's been rounded to the second decimal place. So to 2 decimal places, my imaginary ruler looks like this. I could have gone to 1.25, 1.26 or 1.27. So the places where I would stop rounding one way and start rounding another way are 1.255 and 1.265. Notice that I'm going up to but not including 1.265 for the reasons we just spoke about, but I'm including 1.255. That's always the case. The lower bound is included, the upper bound is not included. Okay, again, pause the video, have a go at this. So each measurement is to the nearest meter. So the width of the field will be between 34.5 and 35.5, and the length will be between 46.5 and 47.5. So our field looks like that, with this length actually being somewhere in that range, and this width actually being somewhere in that range. So the biggest area obviously comes if both lengths are as big as possible, so the area would have been found from that, and the smallest area comes from if both lengths had been as small as possible, so the minimum area would come from that. Okay, a fairly realistic example here. Pause the video, have a go at it, and then we'll see what the answer should have been. Okay, so the first part doesn't involve bounds at all. It just really involves, do you know that speed is distance over time? So at average, over the length of the 100 meters, you are running at 8 meters a second. What's the fastest you could have been, bearing in mind there was some uncertainty about the distance that you actually ran, because it was only rounded to the nearest meter, and there was some uncertainty about the time, because it was only rounded to the nearest tenth of a second. So actually I know that the distance is somewhere between 99.5 and 100.5, and the time was somewhere between 12.45 and 12.55. So say to yourself, if I was actually running as fast as these times would and distances would allow me, did I run the greatest distance or the least distance? And did I run it in the greatest time or the least time? So the greatest speed obviously relates to if the distance was actually as great as possible. So let's say the 100-meter track wasn't marked out very carefully, and the time was as low as it's possible. So let's say that the timer rounded up the time to 12.5, whereas actually it was 12.45. So the greatest that your speed possibly could have been would have been 8.07. Now, some people have quite a lot of difficulty in figuring out where they need to put in the greatest and the least in these calculations. So there is an alternative way, which is simply to write down the bounds of both values involved and then just try everything. Try 99.5 divided by 12.45 divided by 12.55, 100.5 divided by 12.45 divided by 12.55, and see which one gives you the biggest. So if you can't see this, it's not a problem. Just try them all and see which is the biggest possible outcome.